All right. Welcome to today's lesson on identifying rules for cubic functions, and this applies to, you'll notice that it applies from quadratics, it applies to cubics, it applies to any kind of function we're trying to find the rule for. You just have to, first of all, understand what they're asking you and then calculate whatever you need to. Now, you might remember that there are a few different forms of cubics. This is the first one. There's also this one here, which graphs the point of inflection. Then there's this one here, which is factored form. Now, sometimes these go in as x values like that. Sometimes they go in as numbers. All right. And lastly, there is general form, which is the most frustrating of forms. All right. So now, looking at this, you can see that when we're being asked to find a rule, we're going to be asked to find a combination of letters. So A or A, H and K, or A and x-intercepts, or A, B, C, D, or a combination thereof. All right. So you first of all have to know what information you've been told, which form is most relevant if they haven't told you, and then substitute information into that form to isolate the variable you've been asked to find. So here's a few examples that are in the set, and they're all different. We'll go through them together and then we'll break them up and look at them one at a time. So it says a cubic function, this is example 30 up here. Cubic function has the rule ax cubed plus bx. So they've told you the form of the rule they want you to use. They tell you two different points, all right, and they want you to find A and B. The fact they've told you two different points is important because you've been asked to find two variables. You need two pieces of information, all right? So think about that. The pieces of information you need has to match the number of variables you're being asked to find, okay? Example 29, it says, here's the form, here's the point. Find the value of A. So 1 point, 1 variable. B, here's the form, here's the point, variable, 1 point, 1 variable. Example 31 is not written, it's a sketch. So it says determine the rule for the cubic function. So when I look at this, I think to myself, easiest things to use are x-intercepts because that gives me factored form. So I know it's going to have a repeated factor here, a linear factor there, and my third point is there. So what would be the only piece of information missing from factored form that I need to use this point for? And that would be to find A. For B, it's in point of inflection form. All right, so I've been given a point here. Am I able to read where the point of inflection is off this? It looks like I am, and I'd say that's what they want me to do. I wouldn't encourage that in general because it's a bit iffy. But then again, you want to match up the graph to the form you've been asked to find. Then example 32 is different. All right, it gives you a rule. It gives you 4 points, and if you're not skilled at reading what these points are, I'd suggest you practice. So this point here is 1, 0, because that's the input and the output. The next point is 2, minus 7. The next point is 4, 27, and the next point is 5, oops, bracket in the wrong spot, 5, 80. So you notice that they've given you 4 points of information and you're being asked to find 4 variables. All right, so that fits with what we know. This one we'll come to do on our CAS. We're not expected to do it by hand at all, so don't stress about that. So let's go back to example 29 and we'll work our way through. I won't do all of them because they get repetitive after a while. So we'll have a look at the first one, A. We've got the form, the point, the variable. So I've just got to interpret this. I know that it's 10 equals A bracket 3 minus 2 cubed plus 2. 10 equals A 1 cubed plus 2. I'll move the 2 across, so I end up with 8 equals A, because 1 cubed is 1, and there's A. So the last thing I need to do is to substitute this back into, oops, don't need another equal sign there, this back into the initial equation in place of a. And the reason I do that is because I'm being asked to find the value of a in the context of the equation. All right, I won't bother with b for that one. We'll have a look up here at 30, and I'll do it above it. It's got 2 points, 2 variables. So let's do point number 1. This is where I'm going to have to use simultaneous equations. A1 cubed plus B1. And my other equation is going to be 30 equals A2 cubed plus B2. So simplify here, I get 16 equals A plus B. I get 30 equals 8A plus 2B. I will rearrange this to become A equals 16 minus B. I'll substitute that into here and I end up with 8 times 16 minus B plus 2B. 30 equals 8 16s are 118. Does that sound right? Nope, I think it's 128. 128 minus 8b plus 2b. So we ended up with minus 98 equals minus 6b. So then divide by 6 and you end up with 49 over 3 equals b. Sub that back into a and I end up with a equals 16 minus 49 over 3, which I end up is minus a third, because 16 times 3 is 48, minus 49 is that. So the final step would be to sub those back into the equation as y equals minus a third x cubed plus 49 over 3x. We'll pick one of these. I like doing ones with factors, so we'll do that one instead of the bottom one. So I know the form looks like this. Squared x minus x2. So I'm going to sub in what I know first of all. So it's going to be x minus 2 squared, x plus 1. Then I'm going to sub in the final point that I've been told also, which is going to be 3 minus 2 squared, 3 plus 1. So from here I just simplify. 1 squared times 4. 2 equals 4a. So then divide by 4, end up with half equals a. So then, therefore, y equals a half x minus 2 squared x plus 1. Whenever you're being asked to find the rule, there's nothing that says that you have to, if there's nothing that says you have to put it in a certain form, you can put it in the form that's easiest, and factored form is one of those. So I don't even need to expand it, so long as I've got the important information of the a value and the x-intercepts. All right. So those 3 examples we've just done by hand sort of take you through what you need to do. You need to substitute the points in, sometimes using them simultaneously, sometimes not, and then simplify, simplify, simplify until you find whatever you've been asked to find. Most of the time, the one you'll be asked to find is an a value, the dilation factor, because it can't be read off a graph. It has to be calculated. All right. It's up to you to choose which form to use. Obviously, for this one here, B, that I didn't do, I wouldn't use the same form that I did in A. I would probably use this one here and sub the information in that I know to find out the A value. All right. So now moving on to this one here, example 32. We could do this by hand, and you guys know the basic idea of how to solve some equations simultaneously, any number, all right? But there is a special function on your CAS that you can do this with. You're looking for the button that looks like this. So it'll have the curly bracket. It'll have, I think it's 2 boxes. One of them will be black. If you click that button, it brings up a, on the screen, it looks like this, which is very similar, but it's got one key difference. It'll actually have a line and another box afterwards. And the way it read it is this equation given that this. All right, so we're going to use that by entering equations in these boxes here and the variable we'd like to solve for in this box here. All right, so if you click that multiple times, it will add in extra lines. So the first time it adds 2 lines, every time after that it adds another line, and we need 4 lines, one for each of these simultaneous equations. All right, so click that 4 times. I'm going to show you what it looks like from the textbook. All right, so we can see here that they've clicked this button. You have to hit it twice more to get 2 extra lines. All right, what they've actually done first of all is they've defined the equation, and the reason they do that is because otherwise they'd have to type in this equals 0 or this equals -7. So if you define it first, you can just simply type in f at 1, f at 2, f at 4. All right, and then in that little box afterwards, you separate your variables with commas. All right, so you need to put in this box here what you're solving for. In the left-hand side, you put in your equations that you're using simultaneously. All right, so first of all, define your function, then hit this box button, and then enter your equations and variables. All right, once you press enter, it will tell you what they all are, and then the last thing to do would be to rewrite the equation using those variables. So 1x cubed plus 1x squared, minus 17x plus 15. All right, taking extra care with negative signs in the variable if there are already negative signs in the equation. All right, so key points, you need to use 1 point per variable if you're finding multiple variables. You also are not expected to do anything above 2 simultaneous equations by hand. All right, so you can refer to your CAS using these instructions in front of you.